So hi, everybody. Thank you for coming. For those of you who I don't know, my name is Mike, and I work here in Ritmo in the Interaction and Robotics Research Cluster. And some of us in this cluster have been building robots that play music, some of which you see here. And so we're going to spend the next maybe 15 or so minutes demonstrating some of these robots to you. And then subsequently, some of these are set up in a way such that you can interact with them. So either after I've done demoing them or sometime during lunch, you're welcome to come back and play with these. So you can either kind of stick around afterwards and play with them, or you can wander off and get lunch and kind of wander back in later sometime within the next hour or hour and a half or something like that and play with these. And I'm not going to talk too much about the scientific goals behind all of this right now, but that's also something else you're welcome to ask me about during lunch. So there are 4 demos, and the first one is this thing over here. So these little octopus-looking robots, I call them Dr. Squiggles. And these are musical tapping robots. So they basically just sit there and tap out rhythms on whatever surface they happen to be sitting on. And they also listen through contact microphones, which is this thing right here. So the way I have this set up now, these 2 robots are listening to this robot, and this robot is listening here. And I'm going to play some rhythms here, and this robot can only hear me, and these robots can only hear this robot. And so once I start playing, what you'll hear is the robots. First, you'll hear them start to synchronize with my beat. So they'll kind of match my beat and tempo. And if I play the same rhythmic pattern over and over for a while, you'll hear them start to play something that is similar, although maybe not identical to what I'm playing. And then if I change tempo or if I change to a different rhythmic pattern, you might hear the music fall apart a little bit. But over time, you'll hear everything kind of come back into synchrony as the robots adapt to that change. Okay. So without further ado, I will do this. Thank you. Okay, so demo number 2. So these robots don't really deal with pitch at all, even though some of them are sitting on pitched instruments. They don't really have any concept of what pitches they're playing. But because I wanted to study that a bit more, I built these things over here. And so these are acoustical pipe organs. So this is an organ pipe. And so each robot here has 8 organ pipes, and consequently, this robot can play 8 notes. And then each robot is listening, this time just through a regular like omnidirectional microphone. So I'm going to sit here and play guitar, and each robot can hear me, each robot can hear itself, and each robot can hear all of the other robots. So the robots all hear everything, basically. And because each robot can only play 8 notes, no robot by itself can play very much interesting music on its own. But somehow if the robots listen to each other and work together, then maybe they can create interesting music kind of in collaboration with one another. So basically what happens is that every moment in time, this robot needs to listen and figure out whether or not it's appropriate for it to play any of its 8 notes. And we're using some kind of fancy machine learning thing for that. And so we have air.
Can I just ask, do they all have the same 8 notes? No.
No, they're mutually distinct. So it's 2 octaves total. Yeah. They don't really distinguish between musical and non-musical sounds, so they just play along with whatever. Yeah, so that's that. And then, so I'll move over here now. So this is a different project, not entirely related to the other 2 things that I've shown you. This is something that I'm calling Professor Plucky. And it is kind of part of a prototype guitar robot, well, obviously. And it doesn't really fret the strings at this point. It only plucks the strings. And the reason I built this is because we were interested in studying robot movement and how the movement of a robot affects the way that people interact with it. And so, this one is not a kind of interactive demo, but I'm just going to press play on my laptop. And what you'll see, first of all, this will play a little bit of music without visually appealing movement. So you won't really see it moving very much. And then subsequently, it will play the same music kind of with visually appealing movement. So. And it looks like maybe one of these is malfunctioning a little bit, which is why more recently I've been working on kind of a more sophisticated robotic plucking mechanism. So stay tuned for this kind of thing. And then, so the last demo is robot built by Mushtaba, who's going to demo it for you.
Hello everybody. My name is Mushtaba, and I'm a PhD at Ritmo working with robots. So here we have a prototype of a drum robot. So this might be not as interesting as what Mike was showing. But the aim of the robot is to learn drumming tasks by interaction. So the first thing is that we need a body of a robot that can play drums with specific physical properties. Here, this robot has 2 degrees of freedom actuated by just one actuator. The actuator is a special type of direct drive servo motor. And the thing about this motor is that it is able to control the force and speed and position of the joint in different control modes. And the second degree of freedom of the robot is a passive joint which has springs. The springs are used here to make the robot be able to use the rebounding forces of drum membrane. So here I can show some basic drumming patterns just programmed to play by the robot. But in future, the robot is supposed to learn these patterns by playing and interacting with the instrument, and maybe in future with other instruments and other maybe drummers or players. So the drumming tasks may be as simple as a very single stroke drum roll like this. As you might understand, the frequency of the drum roll is really important, and it has a really has a physical connection to the stiffness of the springs here. And this stiffness of the spring make the robot able to play other drum rolls like a double stroke drum roll like this. And all these different patterns can be performed by the robot if the robot can learn how to control or how to update its controller to generate these kind of patterns. And eventually it might learn more complex rhythmic patterns like this one. And as you might recognize that this is kind of combination of double and single strokes, and this might emerge by changing the control patterns of the control of the robot. Yeah, this was it, and we have other things to show.
No, that's it. So that concludes the demo.
Yeah.